Hello, welcome. Let's have a little discussion on the total surface area of a sphere and also that of the curved surface area. Taking this is our sphere, cutting it on the blue line, form a circle. Let's visualize a sphere as a tennis ball, an orange, or a football. Let's take the orange for example. If you cut an orange into two, you see that the opening where you see the flute is going to be a circle, right? That circle is what we are seeing as blue. We can cut it vertically also. You still form a circle. So from the center to the circumference will be the radius. Center, circumference, radius. So two of these give us the diameter. So two of a radius give us the diameter. And this diameter is also forming the height of the orange. When the orange is on a table, how tall is the orange from the ground? Vertical height, which is the same as the diameter. Now, if we take a cylinder of equal radius and a height, meaning the height and the height, which is the diameter and the height of the cylinder, should be the same. So when we place the orange, which is of the same diameter and the same radius, with that of the cylinder, then we can think of the curved surface area. Don't forget, a cylinder has only one curve. So the curved surface area equals to the total surface area. The curved surface area of a cylinder is different from the total because of the opening. In this case, the two openings are taken away. So now we are only referring to the curved surface area. And this curved surface area is the same as that of the cylinder. The curved surface area, which is the total surface area of the cylinder, is the same as the curved surface area of our cylinder. So let's take it this way. The curved surface area of the cylinder is the same as that of the total surface area of our sphere. So we can recall that the curved surface area of a cylinder is given by 2 pi r h. Remember, we developed this in one of our episodes. Now, in this case, we are having a height, which is here. The same height is what we are having as the 2 pi, the diameter. So if you want to find the total surface area of a sphere, which is the same as that of the curved surface area of the cylinder, that means I'll be having 2 pi r h. And what is the h here? For the sphere, the h is 2r. So now let's multiply the constant together. That gives us 4 pi r times r will give us r squared. So the curved surface area, or better still, the total surface area of a sphere is 4 pi r squared. Now, we also know we have what they call the hemisphere. This is a sphere. Cutting this on the blue line produces this. So this is going to be the radius. Now, a hemisphere, let me just say, a hemisphere is half of a sphere. So the total surface area, let's just say total surface area of a hemisphere is going to be pi r squared, just 2 pi r squared. I believe you get why the 2 pi. Half of this is half. If you take it, it's a complete sphere. Half of that, meaning half of this, will produce this. You can see that this is pi r squared plus 2 pi r squared. If we take this as y, the whole of this pi r squared represents y. This will become 2y. So 1y plus 2y will give you 3 of the y. So this means that we have 3 pi r squared as the generalized formula for finding the total surface area of a hemisphere. Don't forget, the curved surface area is half of this, which is 2 pi r squared. That's the curved surface area of a hemisphere. Then the total will be the curved surface area plus the base area, which is the pi r squared. So both give us 3 pi r squared. Don't forget to come back to this page for us to take a question to relate these together. Thanks for watching. Like, share, and comment. Bye-bye. Bye-bye.